Then J.J. Thomson, who is very famous for the discovery of electron. So right now what I'm telling about J.J. Thomson is, J.J. Thomson, by that time when the cathode rays were discovered, he gave the value of a charge to mass ratio. E stands for charge on an electron. M stands for mass of electron. So charge to mass ratio of electron. So he found this. And what is charge to mass ratio? Actually, people remember it. It's not a very difficult number. Approximately, because how things are easy for us is every time we use a word approximate. Approximate means few decimal variation, not beyond that. 1.75 into 10 to the power 11 charge, so coulomb, to mass, so by kilogram, coulomb per kilogram. So charge to mass ratio. So it will not be difficult the way you remember acceleration due to gravity or gravitational constant. That also comes in like this, only 10 to the power minus 11, there it comes. It comes like this. So charge to mass ratio of electron is this number. Charge to mass ratio of a proton is 4 into 10 to the power 7 coulomb per kilogram. So only two numbers are there for charge to mass ratio. One for electron, one for proton. Neutrons are chargeless, massless. So people have no, like nothing to bother about remembering. But this is a good GK question. And then G.J. Stroni. G.J. Stroni, this is the person who gave the name of electron, who named. This chapter is actually very, very interesting chapter. People like this chapter. So what is a discharge tube? Discharge tube is a tube or a glass tube, a narrow, long glass tube, which gives discharge of some kind. That means light discharges or light flashes. Okay. So a discharge tube, its length somewhat approximately 30 to 40 centimeter long, and thickness or width approximately 2 to 3 centimeter wide. So most of the discharge tubes are of this dimension. The discharge tubes will have at the extreme ends two metal plates. Which will be the metal plates? The metal plates can be any metal, because when this experiment was performed, the metal plates also were changed to see whether when we change the metal plates, is the output of the experiment changing. Okay, so these are metal plates which are called electrodes, and these electrodes are connected to high voltage. How much voltage? Voltage greater than 30 kilovolts. Okay, so these all are constant terms that I'm using, things to be by-hearted. And this discharge tube is connected to a vacuum pump. It is connected to a vacuum pump. And what the vacuum pump is going to do? Vacuum pump is going to evacuate any gas or air that is trapped inside this tube. Okay, and these are called electrodes. Electrodes which are made up of metal plates. Which metal plates? I'm saying no, different metal plates were tried. That means first time when coincidentally something was seen, then they said that, oh, what is this happening? Now let us change every dimension of this device. And when they changed the dimension, they found the same effect. Then they came to some other conclusion. Okay, right. Now in this circuit, one ammeter is also connected. One ammeter is also connected. What is an ammeter? Ammeter is a device that senses the presence of electric current in a circuit. Okay, and say there is a plug key. Now here what happens, in this discharge tube, there is some air or gas. Say for example, once the circuit was closed, the ammeter showed a deflection. And that was the biggest question that the people who were looking into this discharge tube, this one, they had a doubt that when the electrodes are not in contact, you see one electrode at one of the corner, another electrode at another corner, these two electrodes are not at all connected to each other. But when the circuit is closed, the ammeter is showing deflection. Means what will be understood out of it? That there is electric current as if the circuit is closed. Okay, so then they doubted that definitely between the electrodes there are some particles. There may be some particles which are responsible for the current conduction. So what they did is to check exactly what is going on. The longer one is positive terminal, the shorter one is negative terminal of this DC source, direct current source. Okay, the electrode which is connected to the negative terminal, that is named as cathode, and the one that is connected to positive terminal was named as the anode. So these are the names. Okay, so very quickly I'll finish off this topic. What they did is, in the anode, they prepared a hole. See, I'm doing a yellow color hole on the anode. And behind the anode on the screen, they coated a coating of a fluorescent material. Say, for example, zinc sulfide. Zinc sulfide is a fluorescent substance. So at the center of the anode plate, they created a hole, and behind the anode electrode, they coated a fluorescent. I just removed those all what I did there. First, the hole was made in cathode, and behind the cathode, the fluorescent, and then nothing happened. But next, what they did is they made a hole in the anode, and behind the anode, the fluorescent material was fluorescent coating was done. And this time when they closed the circuit, the ammeter gave deflection and the fluorescent material started sparkling. And then they realized that definitely some objects or materials from cathode must have traveled all the way towards anode and must have escaped the hole and striked the fluorescent coating. As a result, the fluorescent part started glowing. Okay, so a long glass tube, end points are metal plates connected to a high voltage, high tension source. How much voltage? Extremely high voltage. And inside the fluorescent tube, some air or some gas at very low pressure. In fact, this fluorescent sparkling they have seen when air pressure inside the discharge tube was very less. When more air was there, no sparkling was there. When air pressure was approximately equal to 0.001 millimeter of mercury. Okay, a simple barometer reads or gives a reading like this. So when air pressure inside the discharge tube was this much, it is very less, then only the sparkling was seen. And by the time the air pressure was raised, that means amount of air was more inside the discharge tube, approximately 0.01 mm of mercury, no fluorescence was seen. No fluorescence for more air pressure. More fluorescence was seen, or that sparkling was seen for less air pressure. Okay, so discharge tube is a glass tube which is quite long and less wider. End points are metal plates, which are many points are there, many factors came in. When less air was there or less gas was there, then sparkling. When the hole was there on anode and behind the anode the fluorescent material was there, then sparkling. But when hole was there on cathode and behind the cathode fluorescent, no sparkling. So these all gave a certain conclusion that there are certain charged particles which are traveling from cathode to anode, because behind anode sparkling was seen. One. Number two, less air pressure or less gas pressure. When gas pressure is less, whatever amount of gas was there, through that those typical particles which were unidentified by that time, those typical particles were able to ionize the composition of that gas or air, and those ions, which are charged particles, became responsible for the conduction of electricity, due to which the ammeter was showing deflection, indicating the presence of electric current. So these were certain things. Experiment. And what was the output of this? Output is they gave some conclusion. One, the rays that generated from cathode and went towards anode to create fluorescence, those rays were named as cathode rays. Who named it? William Crookes. William Crookes named them as cathode rays. So cathode rays. So what output I'm saying? So what are the observations? Observations of cathode ray tube. Cathode ray tube experiment. Cathode rays travel in straight line. They travel in straight line. Okay. If they have not traveled in straight line, they will not create fluorescence behind the anode. So cathode rays are deflected. They are deflected by electric as well as magnetic fields. They are deflected by electric as well as magnetic field. And this why that sparkling was produced, or these rays, cathode rays, had the property of ionizing any substance. No, not because of sparkling. You see, these two electrodes are at the extreme end of this long 30 to 40 centimeter long tube. Between them, no water, no wire, nothing, but still the ammeter is showing deflection. That means between them, there are some charged particles. And who created the charged particles? The cathode rays had the ability to ionize whatever substance was there inside in form of air or gas. Ions means what? They will be positive or negatively charged. So cathode rays can ionize any gas. Cathode rays produce fluorescence. What is it called? Sparkling or shine, when gas pressure or air pressure, is less. Gas pressure is less. Less means, I don't know the book writes or not, approximately when gas pressure was at 2 less, 0.001 millimeter of mercury. So few findings. The rays travel in straight line. They can produce fluorescent effect. What else? They are if affected by electric, and these are the basic things. Okay. So that was about the discharge tube. Okay. Now.
By photographic rays.
What are of a discharge tube? This discharge tube experiment was further continued by Roentgen, Roentgen. And what happened accidentally to Roentgen is, it all happened accidentally. You must have read in the properties or nature of cathode rays. I'll come to that. Okay, the screen also I'll have it so that I can show you again. Okay, so Roentgen, accidentally what happened is, a similar kind of discharge tube, not the one that I'm showing you, a similar kind of discharge tube, Roentgen, the way I showed a zinc sulfide, like barium oxide, there was a coating of barium oxide, and such a similar kind of discharge tube showed the barium oxide glow continuously. So what he did is, the discharge tube he covered with black paper. Then also the sparkling, those all were seen. Then what he did is, This discharge tube covered with black paper, he placed it on a photographic film. That part of photographic film where the discharge tube was placed was blurred, means spoiled. Later on, it all happened accidentally. That means he was holding the photographic film. His hand was between the discharge tube and photographic film. And after some time, he saw some kind of formations on the photographic film. During that time, Madame Curie, Pierre Curie, they said that those prints that you see on the photographic film are actually your hand prints. That means definitely some rays must have come from the discharge tube. They must have traveled through your palm. Those rays could pass through the flesh, blood, skin, but could not pass through the bone. So the bone's outline picture came on the photographic film. So this is how accidentally certain kind of rays were identified by Rontgen, and Rontgen named those rays as X-rays. Okay, in a way. Okay, when I draw the diagram, you will know that there is a variation, construction variation is there. I'll answer that question of yours. That cathode rays can spoil photographic film. You know, these days we have latest cameras which doesn't have a reel. Just some 10 years back, if we go, we had Kodak cameras or some similar kind of cameras which will have photographic film. Those photographic film, if they are exposed to light, UV rays will spoil those photographic film. Okay, that means high energy radiations have the ability to spoil a photographic film. These electrons or cathode rays are also, they also possess some amount of energy which may not be very high, but they can spoil photographic film. Okay. So I think rest all whatever properties or uses of cathode rays are written in the book. I don't have that. I have the book, but I did not keep that page open. But you will find those all, the same points that I discussed with you. I discussed what to you? I said cathode rays travel in straight line. How we come to know? Because the picture tube behind the anode, only that part was sparkling. The complete discharge tube was not sparkling, to tell that cathode rays are just like a source of light which propagates in all direction, creating a spherical wavefront. Not like that. It went straight. So cathode rays travel in straight line. Next, they were deflected by electric field and magnetic field. So when this discharge tube was placed in electric field, these rays took a sharp bend towards a positive plate, indicating that these are definitely negatively charged. And they did deflection in, they deflected in magnetic field also. But magnetic field, when they are placed, we can't tell direction. We can tell direction by applying Fleming's left hand rule, those all. So they deflected. That's why I said cathode rays are deflected by electric field as well as magnetic field. That means these are electrically charged. That is a hint that whatever rays were produced from a cathode ray to anode, they are electrically charged. That's why they are affected by electric and magnetic field. Cathode rays can ionize gas. The third point that I wrote. How I come to know, or how anyone come to know that cathode rays can ionize a gas. Any gas is a molecule. Molecule is must be having a cation and an anion. It can ionize. It can separate those. How we come to know? Very simple. In this discharge tube, the electrodes are at far end. Between them, some gas or air is there. Air is also a combination of gases. So still, though the electrodes were not connected, when the circuit is closed, ammeter was showing deflection. That means that definitely there is a conduction between the cathode and anode. So there are some charge parts. These rays must have ionized the gas between them, and those ions, which are charged particles, would have been responsible for the current conduction. So they can ionize the gas. This is how they could have guessed. And this is more important. Cathode rays produced fluorescence only when gas pressure is less. High pressure or more amount of gas or air inside the tube, no fluorescence was seen. No fluorescence, even ammeter may not have deflected to that extreme extent. Okay. That's what a discharge tube, and that's what the properties of cathode rays. Beyond this, any other point you see in the textbook, you can just tell me, I'll explain. These are the basic properties. You can remember here At what atmospheric pressure inside the discharge tube fluorescence is seen? 0.001 millimeter of mercury. At that air pressure, fluorescence is seen. And when the fluorescence is not seen, when pressure is more, at 0.01, 001 seen, 001 not seen. More pressure not seen, less pressure seen. Okay. Right. So this discharge tube, when Rontgen was accidentally working on the discharge tube of a similar kind, he discovered certain kind of rays which has the ability to pierce through as flesh, blood, skin, but not able to pierce or pass through, penetrate bones. Accidentally it was found and he named them as X-rays. Okay. But Rontgen accidentally found, but there was William Coolidge. This is the person. Okay, these people. Okay, so William Coolidge, he designed. Rontgen accidentally found X-rays. I told you that what happened is that discharge tube he covered with black paper. Then also he was able to see the fluorescence created by barium oxide. Then he wrapped with photographic film, as you said just now. Then photographic film was fogged. Fogged means photographic films are actually dark in color. Some silver chloride or some coating will be on that, dark color, oxidized form. So they become white, patched, fogged. Okay. So, and then when his hand was there between the photographic film and the discharge tube, some lines appeared on the photographic film. This he did not understand. For the first time when he saw those lines, he didn't understand what happened there. And this is a nice story actually, that the Madame Curie and Pierre Curie, those who are responsible for the radioactive decay, those all they studied further. They said that these are actually your hand palm prints which has come. And then he said that definitely from the discharge tube, certain kind of energy radiations which are capable to pierce through my palm but cannot pierce or cannot penetrate my bones, they must have released. And those unknown rays, he named them as X-ray. But Rontgen did it accidentally. After this, William Coolidge designed a device or a discharge tube by which those rays can be produced. So he designed a discharge tube that can produce X-rays. Yeah, in simple words, how X-rays are produced? X-rays are produced whenever fast moving electrons hit a metal plate. So how X-rays are produced? Any fast moving electron, if it hits HITS, hits a metal plate, then definitely due to that kinetic energy, lot of heat energy is produced. Other than that, some other radiations. The other radiation name is X-ray. This is how X-ray is produced. So how does William Coolidge discharge tube look like? William Coolidge discharge tube looks like something like this, a spherical with cylindrical ends. It looks something close to like this, and through one of the ends, a tungsten filament. Okay, when you study electricity chapter in class 10th, you will know that why filaments are made with a tungsten only. Okay, so certain things are there. Those answers are very interesting answers, in fact. So this
They
is
have high melting point.
excellent. Tungsten, they have high melting point. They can withstand, they don't oxidize at lower temperatures. Though a filament bulb can acquire a temperature of 2700 degrees Celsius. Their melting point is 3380 degrees Celsius. So it is a tungsten filament. Okay. And this tungsten filament is coated with a barium oxide. So it is coated with a barium oxide. So it has a coating of of barium oxide. I'm writing barium oxide instead of writing the formula because different oxide forms may be. Okay, so tungsten filament will be connected to the negative term. That is, this will behave like cathode. And what is the purpose of cathode? Purpose of cathode is to produce cathode rays, means what? Electrons. Now we will see that these electrons which are produced at the tungsten filament will hit hit a metal plate. As a result, X-rays are generated. Okay, and this tungsten filament is placed inside a molybdenum cylinder. These all arrangements are to have a concentrated, barium oxide will help more number of electrons to be produced. The molybdenum cylinder inside which the tungsten filament is placed will not, it will concentrate, it produce a concentrated beam of electrons, so that intensity of electrons will be more when it hits the metal plate. So this is one. Another end, we want a metal plate. So from the other end, a tungsten metal which will be in form of something like this, so that a 40-degree angle of hitting is allowed. Like this, a tungsten metal. Why tungsten metal? Very simple. It can withstand temperature. Okay, because now during the heating process, lot amount of heat energy is produced. So this is connected to a copper like rod. And because when the electrons from the tungsten filament will hit the tungsten metal, intense amount of heat energy is produced. So that heat energy has to be extracted. That is why this end, this will be connected to a coolant. Coolant means what? Through one end water is pumped, and through other end simple water is pumped in, pumped out, like this. So a coolant, so that which can extract heat. This one. And the final step is, because it is a discharge tube, the two ends, tungsten filament will behave as a cathode, and tungsten metal will behave like an anode. So they have to be connected to high tension source, means a high voltage. So the molybdenum will be connected to negative terminal, and this tungsten metal will be connected to the positive terminal. And this is negative, this is positive, and this is a high tension or a high potential difference. Very high voltage is provided here. When high voltage is provided from tungsten filament, there will be a density of electrons which will go and straight, because cathode rays always travel in a straight line. One of the properties, cathode rays always travel in a straight line. So they will hit the metal at 45 degrees. Okay, so there must be some reason behind this 45 degrees hitting. As a result, that immense amount of heat energy that is produced, that will be absorbed by this copper, and that will be cooled. In this process, some amount of rays are generated. These rays are called X-rays. Okay, and this was a similar kind of thing that Röntgen was holding on the other day when the storytelling was going on. Okay, so Röntgen was holding this kind of a discharge tube, not the one that we discussed in the beginning. The beginning was just to understand the first, when cathode rays or electrons were discovered. Electrons were not discovered, they were named by Stroni, G.J. Stroni. He named J.J. Thomson's role is very interesting. J.J. Thomson, you will read in your books that J.J. Thomson has discovered electron. He has not discovered electron. He told that, by that time, atom was indivisible, was very popular. But J.J. Thomson said that atom is a divisible and it is made up of tiny particles like electrons. Within no time, Goldstein discovered protons, I suppose, neutrons, Chadwick. And then atom was a divisible and it is made up of tiny, still tiny particles like electrons. I'm saying maximum, it maybe they're talking about the first cathode ray tube they're talking about, because most of the cathode ray tube were in a bit, some 10 to 15 years back, the television screen were cathode ray tubes. Okay, right now maybe some, I don't know what right now. Okay, so length was some 30 to 40 centimeter and width some 2 to 3 centimeter. Okay, so these kind of tubes. The ends, this is connected to some vacuum pump. It is connected to a vacuum pump. It is a vacuum pump. A vacuum pump will do what? It will if a good amount of air or gas is there inside, it can extract it. That means it can evacuate the gas inside. The ends of this discharge tube, which is a glass tube, are connected to two metal plates. These two metal plates are in turn connected to an ammeter across a plug key, and then to a DC, direct current source. Direct current source, and the voltage should be very high voltage. So we can remember that voltage should be greater than 30 kilovolts. 30 kilovolts. So voltage should be very high. Few books write that voltage can be 10 kilovolts to 20 kilovolts. Okay, only the hint is that voltage should be very high. Okay. So this, the positive, the longer one is positive, the shorter one is negative. The positive terminal of the battery is connected to which electrode? That electrode is called anode. The negative is connected to which? That is called a cathode. Okay. And then there may be some gas or air inside. Okay. Now, when the circuit was closed, then whatever be the air pressure, the ammeter showed deflection. This was first observation. And then it was understood that when the electrodes are not even connected, that means the circuit is not closed in whatever way, but then ammeter is showing deflection, its meaning maybe is that there is some medium between the two electrodes that is conducting electricity. And then the further research was done to identify what is that medium. So what they did is they took some fluorescent material, and that fluorescent material they coated behind the cathode and made a small hole in the cathode electrode plate, and then closed the circuit. And then though ammeter showed a deflection, but this fluorescent material, which I just gave it as an example, it may be a barium oxide or a zinc sulfide, few examples of fluorescent materials. Those fluorescent substance did not glow at all when the coating was behind the cathode. But when the coating was behind anode, this coating of, say for example, zinc sulfide, which is a fluorescent material. And a hole was made inside the anode plate. And then when the circuit was closed, the fluorescent material that started shining bright. Now what happened is it shined bright under a certain condition. When the vacuum pump pressure was approximately 0.01 millimeter of mercury and more, this much and more, no fluorescence was seen. But when the pressure was reduced to approximately 0.001 and below, but not a complete vacuum space, obviously. So this much millimeter of mercury, when pressure was brought to this, then the fluorescence was seen. Its meaning is when gas pressure is less, fluorescence was seen. So first circuit, whatever be the air pressure, ammeter was reading. Number two, the fluorescence, when less air pressure, when pressure was less, then fluorescence was seen. Third, what they did is they wanted to study the property. The complete discharge tube did not shine bright. Only the part behind the anode where the fluorescence was painted, only that part was shining. So here they took one hint that whatever rays or whatever things are coming from cathode towards anode definitely are traveling in straight line. So the first property, cathode rays travel in a straight line. And then this discharge tube was placed between another two electrodes, which were connected to some DC source, one of them positively charged, another negatively charged. And then just to tell you that how it is understood, say this part was coated, this part of the tube was coated with, which I'm doing with pink. That part was coated with a fluorescent material, say for example. Then these rays, which earlier traveled in a straight line, they took a bend towards the positively charged plate. So indicating that the cathode rays are must be negatively charged because they bend, they were attracted towards a positive plate. Even when the cathode ray tube was placed between the magnets, then also some kind of deflection was found. So I'm not putting an arrow to tell you which direction deflection. So cathode rays always travel in a straight. This is the experiment. This is a complete experiment. Okay, cathode rays were first discovered by Crookes, William Crookes. J.J. Thomson found, that's, we can talk about this also here. J.J. Thomson, by that time, he has given the charge to mass ratio of electron. He calculated in a way, which is approximately 1.75 into 10 to the power 11 coulomb charge to mass, means this much. Okay, and by the time Millikan's oil drop experiment showed that charge on an electron was approximately 1.6 into 10 to the power minus 19 coulomb. So this was known, this was known. From these two, mass of an electron was calculated and it was found to be 9.1 into 10 to the power minus 31 kilograms. So output of this discharge tube were many. One, cathode rays must be negatively charged or they must be charged because they are getting deflected by electric fields and magnetic fields. They travel in straight line. They have the ability to ionize any gas, otherwise how the circuit is closed. Okay, so these are certain basic things.